Okay, hello everyone. So now let's look at what flow coefficient means and how do we use it. So the flow coefficient describes the flow capacity through a valve. It is an empirically determined constant equal to the flow capacity in US gallons per minute of water at 60 degrees Fahrenheit, which is around 15.5 degrees Celsius, when a pressure drop of 1 psi exists across a valve. So what does that mean visually? So if you imagine you have a piping spool and you have placed a valve inside that piping spool over here, and let's say you have a pressure gauge right before the fluid enters the valve, and you have another pressure gauge right after the fluid exits the valve. And essentially, the equation that you would be calculating the flow coefficient with is this equation, where you would multiply the flow rate with the square root of the specific gravity of the fluid divided by the pressure drop. And the manufacturers of valves calculate the CV based on the flow rate that it would take for a pressure drop of 1 psi to develop across this valve. And obviously the units for CV would be US gallons per square root of psi, and that's because the specific gravity is unitless, and for water it would be just 1. The Q is the water flow rate in US gallons per minute, and the pressure drop is obviously in psi. So it's very important for you when you want to purchase a particular valve that you go to that particular supplier or vendor and ask for the CV value, or if you even look online for their catalogs, they would have different ports for the same valve, and they would give you CV value for each of the valves that they have in the catalog. So why is the CV value important? And there might be a couple questions in your head, and let me address them. So why is CV value important? How can you adjust the CV value for another liquid? Let's say, other than water, if you're dealing with heavier, higher viscosity liquids or lower viscosity liquids. Also, how can you find the capacity flow rate at different pressure drops? We know that the CV value is representative of a pressure drop of 1 psi. However, if you're going to use it in your particular system, you might have a pressure drop that's higher than 1 psi. How can you find the capacity flow rate at different pressure drops? And finally, another question that comes to mind is, we've been discussing resistant coefficients, and we know that resistance coefficients are a function of friction factor. And essentially, you need to find what the resistance coefficient is so that you can calculate the frictional head loss term using the Darcy equation. So how can we convert the flow coefficient, which is CV, that is provided by the supplier, to a resistance coefficient so that we could use it in our modeling? The first question is easy to answer. And the CV is important. The CV value is important because it allows us to calculate the friction head loss for that particular fitting or valve that you are using. It allows us to calculate the friction head loss for that particular valve that you're using. Now, the next question is, how can you adjust the CV for another liquid? And so we're going to be dealing with that in this slide.